So randomly, very randomly, I found out this XSS game or XSS challenge on the internet, which happens to be hosted by Google itself. Basically, it is a beginner level XSS challenge where we need to find out XSS bugs in demo web applications. So I thought, why not record this while solving it? Because you people might like it and it might make a good video material. Anyways, if you want to try this game yourself, pause the video here and click the link in the description and you will be taken to this challenge. Try to solve it, and once you're done there, come back and watch the video. It's your choice to try it out first or directly watch the video. It's just your choice. Anyways, this is the game or the challenge that I was talking about. It says, warning, you are entering the XSS game area. That sounds interesting. It says, welcome recruit, cross-site scripting bugs are one of the most common and dangerous types of vulnerabilities in web applications. These nasty buggers can allow your enemies to steal or modify user data in your apps, and you must learn to dispatch them pronto. At Google, we know very well how important these bugs are. In fact, Google is so serious about finding the XSS issues that we are paying mercenaries up to $7,500 for dangerous XSS bugs discovered in our most sensitive products. In this training program, you will learn to find and exploit XSS bugs. You will use this knowledge to confuse and infuriate your adversaries by preventing such bugs from happening in your application. There will be a cake at the end of the test. Wow, I love this already. I am really looking forward to get that cake at the end. So anyways, let me go right into it. Let me start it without any further ado. Level 1. Hello World of XSS. Mission description says, this level demonstrates a common cause of cross-site scripting where user input is directly included in the page without proper escaping. Interact with the vulnerable application window below and find a way to make it execute JavaScript of your choosing. You can take actions inside the vulnerable window or directly edit its URL bar. And the mission objective is to inject a script to pop up a JavaScript alert in the frame below. Once you show the alert, you will be able to advance to the next level. Right, since this is the first level, I was expecting it to be pretty much straightforward. Now I can look at the client side code, but I don't think I need to look at it for this application because this looks like a search engine and it's clearly given that this application includes the user input directly into its web page without properly escaping it. So I'll just try to insert a script tag with alert command blindly, so it's the most basic JavaScript payload ever, and yep, that works. Easy and straightforward. Advance to the next level now. Level 2. Persistence is key. Mission description says web applications often keep user data in server-side and increasingly client-side databases and later display it to users. No matter where such user-controlled data comes from, it should be handled carefully. This level shows how easily XSS bugs can be introduced in complex apps. Mission objective, inject a script to pop up an alert command, once again, in the context of this application. And there's another note given here that says the application saves your post. So if you sneak in code to execute the alert, this level will be solved every time you reload it. Alright, so this one right here seems like some kind of a forums application. And once again, there is an input field that takes user input and updates the page by including this user input. Alright, once again, let me try to blindly inject a script tag with an alert command here. And nope, that didn't work as expected because this level is meant to be a little more different than the previous one, right? Well, I think for this we must look at the client side code that is responsible for taking the user input and then updating the page with the same. But before looking at the code, let's try for some alternatives. Basically, using the script tag is not the only option we have to inject JavaScript. Maybe the website has some protection that disables the script tag if it comes in the user input. Maybe. We didn't look at the code yet, so we can't say. I'm just guessing. So alright, we will just try to use the img tag this time to inject the alert command. We'll say img src equal to and some random file name which obviously doesn't exist, and if the source doesn't exist, it's going to trigger the onError attribute of the img tag. So I will just include the alert command in this onError attribute. So when it tries to load the image from this source, which obviously doesn't exist, it's going to trigger the onError attribute that will trigger an alert command. So let's see if it works. Hooray, it worked! Sometimes it's better to blindly go do things before going complex, I guess. Anyways, let's advance to the next level now. Level 3, that syncing feeling. Mission description: as you have seen in the previous level, some common JS functions are execution syncs, which means that they will cause the browser to execute any scripts that appear in their input. Sometimes this fact is hidden by higher level APIs, which is one of these functions that are good. So the application on this level is using one such sync. Mission objective: as before, inject a script to pop up a JavaScript alert command in the app, and since you can't enter your payload anywhere in the application, you will have to manually edit the address in the URL bar below. Right, so this web app, as you can see, has no element to take input from the user, right? There is no text field or anything like that. There are just 3 buttons, and if you click on image 1 is displayed. If you click on image 2 is displayed, and if you click image 3 is displayed. One thing I can notice is when I click any button, the anchor of the URL is updated. For example, if I click on image 2, you can see that the anchor, that is the value after the hash symbol, is changed to 2 in the URL. And if I select image 3, the anchor value is changed to 3. So there we go. This is the point of input that we are providing to the web app. Though it's not in the graphical user interface, we need to actually edit the URL to inject the alert command. Now for this, I definitely have to look at the code to see how the images are displayed based on the anchor value number, because the anchor value number is what we're giving as input to the web application. So I need to definitely look at how images are displayed based on these anchor value numbers. So this is the client side code, and I can see a script tag with some JavaScript code in it, and the comment says dynamically load the appropriate image. So that tells us that this function is responsible for displaying the image on the page. So firstly, a variable named HTML is created and initialized with the value image appended with %% of num. So num is basically the input we are giving through the URL. Anyways, image followed by num and then a break line tag. Next thing, this string HTML is again appended with some new value, and this time a image tag that has a src attribute which is linked to /static/level3/cloud, and then appends num followed by .jpg, which is obviously the extension of the image that is being displayed. So this basically makes something like this, which is obviously the path on the server where that particular image is stored. This is interesting because the input value num is appended to the src attribute of the img tag, and we know that we can inject JavaScript through the img tag by using the attributes like onError or onLoad. The next thing happening is that the HTML of the tab content is updated with the variable HTML, which we just created, and thus the image is displayed. So now we know one thing for sure: the img tag in this web application plays an important role because it has to load the image every time the app is opened or a button is clicked. And most importantly, it is appending the user input to its src attribute. So I think this is possibly the area to inject the JavaScript. Now I start giving input as a single quote, which will close the src attribute of the img tag, and hopefully this source doesn't exist on the server. So then I will type in onError is equal to alert of 1. So finally the input becomes something like this, and when included in the src attribute of the img tag, it must look something like this. And yep, it worked. This one is actually pretty easy. It just took us to read the client side code, except it's very easy. So anyways, let me go to the next level now. Level 4, context matters. Mission description: every bit of user supplied data must be correctly escaped for the context of the page in which it will appear. This level shows why. Mission objective is to inject a script to pop up a JavaScript alert in the application. The name of the web app is Timer, which is a really interesting name. So it has a text box and a button. The default value of the text box is 3. If I click on create timer, it says your timer will be executed in -seconds, and once the seconds are passed, it displays a message showing time is up. Cool, it's a timer application. First, let me see if this text box allows input other than just numbers. So I will type something like this, and it still works. The timer executed in 2 seconds. What if I give no numbers and just characters? Well, it still worked. Seems interesting, so let's dive into the code. So this seems like the home page. Here is the input field that takes the input from us, and there is a create timer button, and this is all in a form tag whose method is get, but there is no action attribute here. I'm assuming that any request from any page is handled by level.py module. And by reading the level.py Python code, I confirmed it. It basically handles all the requests from all the pages and chooses what to show for a particular request that is made. For example, if the index.html sends a get request with the value 3, it is handled by level.py, and then it sends the user to timer.html by also passing the input value to timer.html, which is the web page that shows you that the timer is executing and prompts the user when the timer triggers. Anyways, we don't need to talk about the level.py because it is a server-side code. Right, let's go into the timer.html. There is a start timer function which takes a parameter named seconds, which is basically the input we give, and it firstly passes it to integer, and then it does a logical OR operator with the value 3. Well, I don't know what this statement does. I'm not really a JavaScript geek, so let's find out what the OR operator does when it is used in assignment statements. Right, so this is what it seems like it does. If the first value is a 0, then the second value, that is the value after the OR operator, is assigned to the variable. But if the first value is not a non-zero or a non-null value, it is assigned to that particular variable. Makes sense, right? So this logical operator here is used to set the default value to 3 if the given input is 0, because we can't start a timer for 0 seconds, right? Anyways, then there is this set timeout function that triggers the timer once the timer is executed. But there doesn't seem to be any injection points in this function. So let's go to the img tags now. There are 2 img tags over here, and the first one is simply displaying the logo for this challenge. So it's of no use for us. But the second img tag has a src attribute, which is referring to a GIF loading image. And it also has a onLoad attribute, which consists our input. Now this value timer is the value passed by level.py to timer.html, and remember who sent the value to level.py in the first place? Yes, it is us. So we can inject some JavaScript here, assuming that level.py does no input sanitization. So let's see what input we can give so as to trigger some JavaScript here. First, let me close a single quote. So I will start my input with a single quote. Now I want to execute a alert command, so I will type a semicolon to accommodate more than one statements in the same line, and then I will type in the alert of 1 command. Now we are not done yet. Notice that there is still a colon and a closing bracket that is left, and we need to cancel these 2 tokens, or else we can't get our JavaScript to work. So how do we do this? Well, in order to cancel this, it is the single quote and the closing bracket, let me include another statement here, this time an assignment statement, and I will say where b equal to an open bracket which cancels the closing bracket at the end, and then a single quote which cancels the other single quote. Now everything looks fine, right? Let me try this. Now, since I have a little bit of experience about SQL injection, I know that when we are submitting some characters in the URL, we need to URL encode them first. So in our case, we need to encode the semicolon because we can't simply pass the semicolon in the URL as it is. So we will need to encode the semicolon first and replace it with the encoded version. Again, how do I know that the encoded form of the semicolon is mod 3b? Well, there are lots of online tools using which you can encode any particular character or a set of characters. Just use them. Let's go to the next level now. Level 5. Breaking protocol. Mission description. Cross-site scripting isn't just about correctly escaping data. Sometimes attackers can do bad things even without injecting new elements into the DOM. Mission objective is to inject a script to pop up an alert command in the context of the application. So this is the home page. If I click sign up, I'm taken to this page and I will enter an email here and click next. And then I'm taken to this page which says thanks for signing up. You will be redirected soon. And after a few seconds, I am redirected back to the home page again. Right here, there is one input that we are giving through the GUI of the website, and that is our email. But this input is not included anywhere in the next page or any other page. So there seems to be no use of this email ID input. What else is left? Well, it's again the URL. Let's look at the code, and there are 4 modules of the code given. Welcome.html is the home page, and it has an anchor tag named sign up, which takes us to /level5/frame/signup, and with the parameter next that takes the value confirm. This parameter validation is obviously done on the server side, which is by the level.py code. So before moving forward, let me tell you that in real life scenarios or in real time scenarios where you are testing websites for XSS bugs, you will not be having the server side source code with you. Obviously, the only thing that you can see is the client side code. Now, for this same reason, let us try not to look at the level.py module, which is the server-side code. Let's only look at the HTML files and let's try to understand and come to a conclusion. Right. So when we click on the sign up link, we are redirected to this page or to this path with this parameter. And where does this take us? It takes us to this page, which is the signup.html. So if the parameter next is given the value confirm, we are being redirected to signup.html by the level.py server-side code. And in the signup.html web page, there is an input field which takes the email ID input, which is apparently ignored. And there is an anchor tag here as well that takes us to the value of the variable next. Now, what might be the value of this variable next? The value is obviously passed by level.py. Now remember, on the welcome.html, we are passing the value for the parameter next as confirm. So the next in the welcome.html is same as the next in signup.html, hopefully, because it is received from the welcome.html by the server and then it is sent to signup.html by the server. So the value of next here will be confirm. So it is href equal to confirm. And you can see that there are no parameters here. Now clicking on this anchor takes us to confirm.html. So href is equal to confirm takes us to confirm.html. We can come to this conclusion because it is decided by the server side code. That's what we are assuming because we haven't looked at the level.py server side code. Anyways, now the confirm.html have a JavaScript function that sets a timer for 5 seconds, and when the timer is triggered, it executes window.location is equal to the value of the parameter next, which takes us to some location. What would be the value of next here? Well, you can see that here by default we are being redirected back to welcome.html. So that means by default the value of next is equal to welcome.html. But we did not ever set the value of next as welcome.html, right? So probably this is done by the server side, isn't it? But if we manage to set the value of parameter next to some JavaScript, we can make the page redirect to a page which executes some JavaScript. But how do we do this? I spent a lot of time trying to figure out where exactly can I inject the value to this next parameter And I finally ended up looking at the level.py code. I know, I told you not to look at the level.py code, but I ended up looking at it. Well, even if I didn't look at the level.py code, I am pretty sure I would solve this challenge, but it just would have taken a little bit more time, that's it. Anyways, after looking at the level.py code, I found out that the value of the parameter next is set to welcome if there is no specific value that is defined for the parameter by the web page itself. Which means if the web page is passing some value for the next parameter, then the same value is assigned to the next parameter. But if the web page doesn't explicitly define any value for the next parameter, then the parameter takes the value welcome by default. Remember that we are not assigning any value to the next parameter in the previous web page. The href attribute just said confirm and no parameters are defined. So that's why we are being redirected to welcome.html page, because that would be the default value for the next parameter if we do not explicitly define any other value, right? So now this clearly shows us where to inject our malicious JavaScript or our malicious input. Right? We need to inject a link that executes a JavaScript in the next parameter. So simply I can say JavaScript :alert1 to execute a JavaScript alert command. So I will just say /confirm $next equal to, and then I will put this link, which is JavaScript :alert1 as the value for the next parameter, so that we will be redirected to this particular link, which will execute or which will trigger an alert command. So yep, let's try it. And yay, that worked. Now that's very interesting. That's like the most interesting level I've ever had in this game. Let's advance to the next level. This is the final level, by the way. Level 6, follow the rabbit. That's the most interesting name for any level I've seen so far. Mission description: complex web applications sometimes have the capability to manipulate libraries based on value of the URL parameters or part of the location hash. This is very tricky to get right. Other users don't URL links or other data such as the XML request or list of libraries. Mission objective is to find a way to link the application to an external file, which will cause it to execute an command. Now this challenge clearly tells us that you need to make an external JavaScript file to execute from this page or from this web application. And the mission description implies that the web app dynamically loads the JavaScript libraries based on the URL parameters or part of the location.hash. Now location.hash is a JavaScript command that returns the anchor value of the URL, including the hash symbol. So the home page of the web app has a hash followed by some path, which is obviously the path of the JavaScript file. So the web app loads the JavaScript file from this path specified in the anchor part of the URL. And we need this web app to execute a JavaScript that is hosted on an external source, Pastebin for example. So let me modify the location.hash value to this URL of Pastebin, which has a JavaScript alert command. And it says here that it cannot load the URL that contains a HTTP or HTTPS. Now this is because there is a check done on the path of the JavaScript file that is retrieved from the URL. It is checking if this path starts with HTTP followed by optionally an S and then : //. So we cannot inject any URL right here because any URL must start with either a HTTP or a HTTPS. But what if we used, like a space before the URL? Since this regular expression doesn't indicate any space before the H in HTTP, maybe if we include a space before the H, this check might fail, which results in our external JavaScript to be executed. Alright, it says that it has indeed loaded a gadget from the mentioned URL, but the URL obviously isn't the URL that we want to load, because the space here is also treated as a special character, is also treated as a character. Now we did manage to bypass the check, but we couldn't get the external JavaScript to be executed, since the space is also being treated as a character. Hey, so I have spent like more than an hour trying to figure out how to bypass this check, and I completely failed to realize that the check right here is not case sensitive. I mean, it is only checking for lowercase https:// which means it is the simplest thing in the world that can be bypassed. Literally the simplest. If you just type HTTP in caps, that must be it. That must bypass the check. No need to include any space or any other character before the URL. I mean, this level is like the most simplest level on the game, but it still took me more than an hour to figure it out. Well, that happens. Sometimes we may miss the most simple things and try to think about it in a more complex way. But anyways, we finally solved all the challenges and I got the cake I needed. Right, so comment down below which challenge you feel is the most interesting one and the toughest one to solve. Also let me know if you solved this challenge without watching this video. Thanks for watching, hope you liked it, and if you like it, don't forget to leave a thumbs up below and comment down below and tell me what you think about this video. Thanks for watching, I'll meet you in the next one. Until then, cheers!